thing. Okay, so big idea of today is we are going to be talking about calculating or approximating the area of a region bounded by a curve and the x-axis on an interval. Okay, so because we're talking about area, we're going to be focusing on functions that are positive over an interval, so like above the x-axis over an interval, although we'll see later on that this can all be translated to functions that are negative, okay? So this first picture that you guys have, so this is the function f of x equals 2x plus 5, that's this blue line segment, on the interval between 0 and 2. And what we're going to do is we're going to approximate the area of the region between the graph of the function and the x-axis on this interval using 4 rectangles, okay? And we're going to do it in 2 different ways. So 4 rectangles, but the first approach that we're going to use is we are going to use the left endpoint of each subinterval that we create in order to find the height of each rectangle. What's the area? How do we calculate area of a rectangle?
Length times width.
Length times width. Okay, so let's think about this. If we want, you could probably just eyeball this without having to do any actual calculations. If we want 4 rectangles of equal width, what's the width of each of the rectangles going to be here?
1/2.
1/2, yeah. So we're going to think about dividing this interval from 0 to 2 into 4 subintervals. So like we'll have from 0 to 1/2, from 1/2 to 1, from 1 to 3/2, and then 3/2 to 2. And this has a name. We are partitioning the subintervals that will correspond to each rectangle. I always think of like a cubicle in an office, like putting a partition up. What was yours?
Beyonce. It's a song. Oh yeah, partition.
Is that
India?
Yeah.
Oh, that's what I was thinking. We partitioned India. Wow, we went.
You guys
different routes.
are going deep. I'm talking about like the office and a cubicle, but okay.
I was thinking about Beyonce.
Beyonce, yeah, you win. All right, so we're going to think about creating rectangles that we're then going to add up their areas to approximate the area of this yellow shaded region using the left endpoint of each subinterval. So our goal is to come up with an area or an approximation of the area. And when we're using the left endpoint of each subinterval, that means we're doing a left-hand approximation, which I'm going to abbreviate as LH. So let's go rectangle by rectangle. So the first rectangle that we would want to be finding the area of using the left endpoint of the first subinterval would be when x is equal to 0, which would correspond to y being 5, or the function value being 5. So like this is our first rectangle that we are calculating area for. And you guys already told me area of a rectangle is length times width. And the width in this case would be 1/2. And then the height would be, or the length would be 5. Okay, so that first rectangle, we would calculate that area 1/2 times 5. Okay, and then we can move on to the next rectangle. So again, using the left endpoint of the subinterval, the function value at the left endpoint of the subinterval, in order to determine the height of the rectangle. So the next rectangle would still have a width of 1/2, but the height would be 6. So 1/2 times 6. And you could always double check since I've given you what the function is too. Like if you plug in 1/2, then we would get 6 for the function value. And then moving on to the third rectangle, using the left endpoint. Okay, so thinking about the area of this rectangle, You're like, are we actually in calculus right now? We are. We are. And then the height would be, was that 7? And then the last rectangle, the fourth rectangle, still have a width of 1/2. Try that again. But the height will be 8. Okay.
Why don't we include the triangles at the top?
Well, we're doing an approximation. We are approximating area right now using 4 rectangles where we're coming up with the rectangles or the height of each rectangle by using the function value with the left endpoint of each subinterval. Notice how that width of 1/2, don't think, couldn't we just, this is what you've been asked to do. This is the area that we're coming up with, and it is an approximation of the yellow shaded region. So we're going to factor, we could also think about factoring out. I'm just doing this to help us out with the next ones. So we could think about factoring out the width, right? And then adding up the heights. And then you can always double check, but I believe that ends up being equal to 13. Now, all my people are thinking, well, couldn't you just do to get the actual area? Like, yes, you could, but this is what we've been told to do. This is an approximation of the yellow shaded region. Do we think it is an over approximation? An under approximation? Why do we think it's an under approximation? All the rectangles are under, and then there's like those triangles, right? The gaps, right? Where the area has not been accounted for. Okay, so this is an under approximation. And that's because the rectangles that we used, we can actually refer to as being inscribed rectangles. And when we talk about using inscribed rectangles, it means that on each subinterval, to find the height of the rectangle, we're using the smallest function value on each subinterval, which in this case corresponds to the left endpoint of each subinterval because
That's the smallest one.
why is it the smallest?
The slope is positive.
Because the function is increasing on each of these subintervals. Okay, so inscribed rectangles, I'm going to give you a little definition here. The height of each rectangle is the minimum function value on each subinterval, which just happens to, for this particular function, be the left, correspond to the left endpoints of each subinterval. Okay, next we are going to approximate the same area. What color should I use? There we go. Next, we're going to approximate the same area, but using the right endpoints of each subinterval. So I'm going to call that a right-hand approximation, or RH. And then I know the width of each rectangle is still going to be 1/2, so I'm just going to have that 1/2 factored out, and then I'm going to look at what the height of each rectangle would be. So if we're using the right endpoint on each subinterval, our first rectangle could be drawn like so. Okay, so the area or the height, because the area would be 1/2 times whatever the height is. What is the height of that rectangle?
6.
6. And then the height of the next rectangle, again, using the right endpoint, will be 7. Did you guys hear that 6, 7's out?
What?
Yeah, nobody's using it.
No.
No, nobody's using it anymore. It's out.
6, 7 is not out. 6, 7?
No, it is.
We'll single-handedly bring it
I've heard it. I've heard that multiple places now.
Well, you did hear it from me, though.
Well, you can keep using it and like be on out. It's your choice. Okay, and then the height of the next one. And then the fourth rectangle, oops, will have a height of, dun, dun, dun.
Can I see the full definition for inscribed rectangle?
Nope. Yeah, hold on. There you go. My favorite, like, I guess it's not a meme. What is it if it's a video? That's,
It can still be. I think it
is it a meme?
Yeah.
Is it still a meme? No? You know what I mean by that.
You know
It's
what
like the kid saying 6, 7 to the Grinch, like the guy dressed up as the Grinch, and he's like 8, 9. Like scares him. So good. What? No.
I'll watch a video. I'll show you guys.
Okay. I'm missing out.
Send a message to your future self.
Thank you.
Do you have any predictions?
I got the definition.
Okay. What?
They said Tiffany.
No.
I don't know.
Okay, so that ends up being, you can check my math, but I have written down 15. Do we agree with that? Is 15 going to be an under approximation or it's an over approximation? Are we all in agreement? Are we all comfortable with why that's an over approximation?
Yeah.
Okay, wonderful. So it's an over approximation. And using these right endpoints, hold on, I can't multitask that well today. So it's an over approximation. And using the right endpoints, we actually ended up using what we call circumscribed rectangles, not triangles, circumscribed rectangles. And for circumscribed rectangles, the height of each rectangle corresponds to the the maximum function value on each subinterval.
But what's the point of getting approximations if you know how to do the whole thing?
You just gotta trust the process.
Okay.
I get it. Trust the process. Keep thinking, where could we be going with this? Height of each rectangle is the maximum function value on each subinterval. Okay, so we've introduced 2 new terms here. So looking at this, so we have an under approximation and over approximation. That means that the actual area has to be between 13 and 15.
But yeah.
Yeah, duh. So using geometric formulas, what I want you guys to do, because this is, as Anya was saying, like this is something that you could calculate the actual area for. So why don't you let's go, we can just go 2, 2, 2. why don't you talk through calculating the actual area using geometric formulas, or maybe just a geometric formula, to come up with the actual area of that region.
So we can find one triangle and then the rectangle.
Plus the triangle, plus
Should be the triangle plus the rectangle.
times the 1/2, 2 times
Or it could be the rectangle minus the non-existent triangle.
plus,
Like the bigger.
yeah,
Yeah, that's right.
which is 14. Wow.
Oh, yeah. No.
That's the triangle.
Yeah, so it's not.
And then you add
Oh,
the triangle
yeah.
on top. Well, I was thinking you add the triangle on. See, but that takes away all the hard work that we just.
And then you multiply.
If it's
No,
not.
I'm gonna say no. It's
What?
the one that we already saw.
What?
Is it geometric formula one that we already saw? Wait, which one? Like,
Or
did we learn them like last
One
month?
is smaller rectangle.
Wait, what are you saying?
Remainder.
like an area formula.
Yeah, like, no, wait, I'm thinking of summation.
Like think back to like geometry.
I was thinking of summation.
Cheat, I'm a treat. Geometry.
What? Geometry.
Back to geometry.
I took like.
So you could look at this, like what shape or shapes do you see when you look at that region? You could see a trapezoid if you're just looking at the whole region. Some people look at it and they see like a little. I don't see a circle is not what I see. But some people look at this and they're like, I see a little house where there's a rectangle and
He doesn't see it as a.
I see a ladder problem.
and a triangle. Okay, so you're right. So one approach could be finding like the area of the rectangle and then adding the area of the triangle. So like area of the rectangle, that would be what, 5 times 2?
Yes.
Plus area of the triangle, 1/2 base times height. The base is 2. What would the height? Oh, he left a while ago. Nathan? He left right at 2. Remain.
Does Dennis have to go into the closet again?
Maybe just went straight into
No,
the
Nathan. They can't
Yeah,
find.
he just like broke himself.
He said
Dennis is
he was
Googling.
gonna drive Max to his house to get his like soccer stuff.
Oh, I should have. You should have told me.
Sorry, I don't know.
Here, hold on.
I know he didn't want. Oh, sorry, I forgot. Because it was against the rules, which is why he didn't want to.
I mean, why didn't they call him? I can't. They're gonna figure it out. I'll figure it out. Okay. So 1/2 base times what's the height of that triangle? 4. Okay. So that would be thinking area of the rectangle plus area of the triangle. So 10 plus 4 is 14. Or, like Anya said, trapezoids, which, I mean, knowing how to calculate area of a trapezoid is probably a good idea at this point. It's going to keep popping up. Okay? So remember, trapezoid, there would be 2 parallel sides. And then the other sides don't have to be parallel to each other. But we could say this is the height of the trapezoid. This would be side A, side B. So the area is going to be the average of the 2 sides that are parallel to each other times the height. So like looking at this trapezoid, thinking about the sides that are parallel to each other, that would be this side and this side. So 5 plus 9 divided by 2, and then the height is 2. Think of it as being like on its side. And we're like, hey, guess what? We get 14 as well. we okay with that? Okay. Okie dokie. For the next one, why don't we line up youngest to oldest?
This is 2008.
I am.
People go here. Wait, youngest first.
Oh, I forgot to take a roll.
Youngest to oldest?
Youngest to oldest. Yeah, oldest by me.
When are you?
2009.
Huh? Which one?
January.
Oldest over here?
Yeah.
Oh, okay.
That was 15.
Yeah.
Are you 2009?
Yeah.
When?
We went by height, we could mimic the
You was
round.
there.
Where are you?
And then put a line.
I'm no clue.
When are you?
January.
Baller. You come here with like platform shoes. I'm like wearing the same height as you.
So cool.
Everyone wants a little teardrop tattoo.
August 1st.
Are you still recording?
I was. Okay. Let's just go group 1,
Like
group 2, and then go.
Okay,
Okay, so 1, 2, 3.
You said 1 plus 100. 2 plus 99.
Like house. There you go. Okay, go ahead and continue. So you guys, if you would like to use the whiteboard, you can. I know the other class was like, they wanted to just write it in there because I gave the graph. They wanted to just use that. That's fine. Or you can use the whiteboard.
You want to use that one? Oh, are you guys using that one?
No.
Oh.
So that means we get principal for
Do
it.
both and.
But same idea, you're using the left end point of each subinterval.
So.
Sure.
Okay, approximated region.
Also determine whether or not your approximation is an under and over approximation and what type of rectangles were used.
Wait.
Oh, you know what?
Circumscribed or inscribed.
Wait.
I don't want to draw. I just want to do the
Yeah.
You need to
So
draw.
it'd be the big circle, right?
Okay.
So
Okay.
It says 6 rectangles for this one.
Okay, fine. Let's do on the ground.
Okay.
Did you guys read how many rectangles you're supposed to use?
Oh, wait, they're so smart. 6 rectangles.
3. Oh, wait. Oh.
And then
Wait, actually, it's not.
It's a lot of. Six and 4.
Sorry.
What is that? What is the interval? What is 4 divided by 6? Ew.
Wait.
Why are they making us do that?
So,
Wait, what?
starting, you can left.
Where is it?
Yeah.
Yeah. Pretty good. Whoa. Hold on there.
This is pretty strange.
Wait, I think that's wrong. They're not supposed to be the same height. That's not how it works.
Yeah.
No, that one was right.
Yeah, it's this one that's wrong. Oh, it has to
And
be
then
like a
it's
half just size.
Good job.
It's really upsetting. That's half. That's a whole. That's half. It's negative.
No.
Okay, that's
Oh yeah, it goes.
Yeah. Wait.
This is supposed to
I
hurt.
really don't like the. I don't know why.
Is this how
Shut up. Or is this what works?
it usually is?
Wait, no, it's the width. Oh, it is.
It is 1/2.
Oh, I feel like I'm going way too many.
No, wait, it's 1. No, it's 1/2. Wait, I forgot what 2 came out from.
Where'd you get 2 there? 6, 7,
What is 4 divided by 6?
15.
That's definitely right.
Oh, it's because each one is 2. It's 1.
And you guys have the function.
It goes by 1/2.
No, it's 1.
I'm right 14 over 2. It goes by 1/2. So,
What are we doing?
Yes.
That was weirding me out.
percentage,
Draw
2/3.
over
It's
2
just-
plus
1 and 2/3, that's like 5/3.
plus
So each one is
11
like, oh, it's
over
weird.
2.
So we just,
Wait, is that just like the line that will continue? Am I looking at it
I
wrong?
don't know how to do this. We even have to draw it. We don't, right? Wait, do we have to draw the rectangles?
So it starts at 7.5.
We're so dumb.
38
Right.
calculate.
So it's 2/3, and then we do the parentheses, and we do like 6, right? Oh, okay, where are we gonna know?
I like that you open my browser the first thing you found.
Did you get point? Oh,
Oh,
this
no,
is-
the first one. The first one is what we
Perfect.
5, 6, 7.
I forgot it was times 5.
7
It'll be minus 6.
What's the next?
Or minus 6.
How do we know that?
Well, you know, he's a little, get a little tricky with this.
18.7.
There's no
Why
trick
are you
here.
why are you needlessly getting triggered?
18. You did see the sine squared plus cosine squared.
You have no
It's a trick.
excuse to get triggy right now.
Square, second square.
Sine squared plus cosine squared, and you have like the tangent one.
Yeah.
Oh, wait, yeah.
Everyone knows about that.
Wait, no.
When you're adding,
No,
you
No,
do
the
cosine.
first one's 8.
But it's instrument, right?
And the next one's 7.
Yeah.
Wait, I so don't like
Unit
this
squares.
Rishi, I don't agree with your.
Oh, you don't?
Well, I think you
Oh,
forgot
yeah,
to.
Okay.
Then what head?
And then it's gonna be
Two.
less.
Do you agree? A little bit more?
Right, because
Then
what?
5 is 6 and a half.
Okay.
Wait, no, 6
This
and 2/3.
3 times 4 over 2. Which is 6.
Okay, I'm gonna say.
And our overestimation is so.
No, I
really
think
don't
it
know
is.
for sure.
The same stuff. Look at that.
Just a little birdie told me.
Yeah, but we still got.
But yeah, we said the problem.
Okay.
The problem.
Wait, why did they have a?
This is 4.
I think that.
No, this is 3.
Oh.
But it starts at 3, so it's.
Yes.
Why is everything over 2 for that? Yeah.
That's still.
Oh, we're
Wait,
definitely
wait,
missing
wait.
two.
Wait,
Oh,
it's not
like
this
I
is
said,
4, it
like
starts
I
at
said,
1.
10.
So that's
Oh,
what
plus
it
3. Oh, I see.
That's right.
Yeah. You're right.
We're just picking answers.
Yeah.
Okay, wait, but the next one's.
Yeah, because it's
This
1, 2,
one's 6.
3.
Plus 6.
Okay, that's.
Oh, wait, so it's like going down
You
and
count, you
down
can count,
by
you can count.
by 2/3. So
Wait,
it's
3 times 3 over 2 is
divides
not.
1 over 2/3.
Was they know something don't?
Yeah.
1, 2, 3, 4,
Hold
5.
on.
And then the last one is switched.
That's the more. That's 4.
Oh, 2/3.
Really? Okay.
I hope you did not lead me in the wrong direction.
I hope so too.
Yeah, so it is.
I don't know. And then so next
Okay.
thing is 11
I appreciate it.
times
There's no room on how much it
times 3. 11 plus 11 places. 11
And then in your same groups, you can also try the next one. G of X.
Wait, actually, it's okay, it's okay. No, I don't think more time, is that more?
Every 2.
Wait, what color was it? What color?
What color is this?
What?
Why?
No, what color did you stack it with?
That's the next one.
Oh, actually,
Teal?
multiplying by 2/3?
What's the opposite of teal?
Oh, but now we have to like approximate.
Did you guys take pictures?
Yeah.
Want me to scroll to the next one?
Sure. Wait, that means we have to erase it.
Yeah.
Wait, actually.
Just tell me they got it right. Wait, what was? Why was all your stuff over 2?
Oh, I just wrote it that way to make it easier to add.
Wait, but we got like some over 3. We got like.
Bro, are you, maybe you read the graph incorrectly?
Well, each. So you're doing 6 rectangles, right? And from 1 to 4, what's the length of the interval, right? From 1 to 4.
The length, it's,
Should we?
No, wait.
oh, it's
maybe
3.
things?
Right? So then
It's 3.
if you're dividing into
Oh my god! We did 4 divided by 6.
It's probably still there, but now I just smell like cat.
We're so
Like,
dumb.
interesting little, like,
Okay.
Like, yeah.
No time thing.
That was your fault.
You erase.
Okay, I'll erase.
I knew they were right. You're always
Look,
on
these are what
something.
now?
Okay. We did 6 right?
Oh yeah,
It's just 1/2.
we're not changing
We're
this.
so dumb. Someone needs to kill us.
and then your that's
Wait.
dramatic.
What happened?
And then your graph.
So just wait this one half. This one
Yeah.
is start on side. And then this is.
Okay. Wow. 4 rectangles. You got this.
I'll do left.
Wait, it's just a highlighted section.
Just the highlighted region.
Okay.
Yeah, we would have been done by now. If we were really smart. Yeah, we're like, oh, 4 divided by 6. Whoa.
5.2 plus 10 plus 7 plus 17.4 over 2.
Okay, it's consistent throughout. 8. And then just 8.7. Yeah.
And now you can draw your.
Equals your
Wait, no, I'm doing the left.
No, you should do the right ones. That's like.
Very good, pretty good, pretty good.
So bad. Okay. Okay.
Yes. 1, 2.
I'm glad you think it's
That's
okay.
1/2. Okay.
Oh, okay, I have to do the right thing.
What am I doing? Hold on.
Yeah, I think it would just be like this.
Yeah, let's see.
3.25. That's in like 3.25. Can we approximate that to get it to?
You're not approximating, right? You have the actual function value or
Oh,
function.
that's it, solve for.
Oh.
Okay, let's
Okay.
go over
We
here.
just add 2 or 1.5.
Yeah, so
Okay,
we'll
we
put
have
five.
1.5. Can you do 1.5 squared plus 1?
I feel like this is boring because I'm recording, but they can't.
Oh, you were, that was your fault. That was so
3.25.
Oh.
What? No.
Wait, you want to see my photo face? This is my photo face.
Hold on. Hold on. I don't know if we'll leave it. All right.
This is
There you go.
3.25.
Wait.
Okay. What is this? 2.5 squared plus 1?
Wait, that seems so. Is that like another solid?
Wait, why did I get spaghetti? What was I doing?
Look at it. And then this is 17.5.
So is that 10.5 plus
Really, 81 over
7?
Wait, I forgot to write it left.
What?
What I did earlier.
What 81 over 2? That was wrong. Wait, how did you get 2?
Perfect.
Can't just do it again, but.
Why are you using virtual or live? Like, you really can't say it.
Wait, I think you had low. Right. Wait. I think I did this one.
Okay, what did you get?
So is it here then?
Why 81 over 2? But I don't know, that's not what they asked.
Okay, what did they got? They got
Yeah,
it
right.
right.
Wait, is this
Oh, the,
That one whole other question. What are we doing?
no, but it says start.
Let's just move on.
Wait.
Yeah, I think I got this 21.
Wait, why is it there?
Oh wait, I'm really sorry about that.
Because it's the maximum value for between 2.5.
Okay, I'm moving on.
Do you want to check
You're
that?
not
You
using it.
We think we're wrong.
Yeah.
And we just did the first question. So, is it 20.25 for A?
Yeah.
Oh! What did you get?
81
Wait, I need to.
That's not right.
Wait, but it's not on the thing. So is this?
I don't know, do you have?
I'm not sure if I find this stuff.
Oh, well, that line,
7.5, 7, 6.5, 6.
if it's like
Okay, so that's
3.25,
correct, and
it
then
would
times
be
1/2.
like you're drawing.
So,
Yeah.
whenever you add it.
You want it to be
Oh,
here.
I did what I did wrong.
Straight up.
Like that, like that.
Yeah.
I got it. Okay, so what is that? You said 3.25. Oh.
Wait, it's not.
25.
Okay.
Oh, really?
Are you bleaching out his sweatshirt?
No, it's because I got marker on it.
Now I'm just, it's gonna be so clean, it's gonna lose all of its color.
I'm still.
How do you not know you're about to graduate?
There's still like a.
25.5.
Is 8.75 correct?
Wait, I have to. No,
That's what I got.
Okay.
You need it.
Over.
That's not a big difference.
Wait, what did you get? Oh, is it?
Yeah.
Oh, I think I got it.
That's what I got.
Oh, they got a different one. Well, you just
Well,
got
because I
your
have
receipt.
13 and not 3.
Oh.
Because I chose to do it that way.
Alex.
Like Alex
I mean, it is no worse.
You don't know.
Yeah.
Technically.
7 plus 6 is
Okay.
13.
Agree.
Just ask to find the middle one.
And then like.
Because we can't without estimating, right?
What's 18?
Or I guess we could just like try to estimate.
Oh, wait, should we do the next one then?
Exactly.
Not yet.
Yeah. Actually, I completely forgot how to do it, so,
That's fine.
yeah.
You will do it and you'll be like, oh, I remember that.
Yeah.
Since you never do an office here, I think that's the right way.
The typing isn't working.
We have like the next step, but then I don't know. This is the
Oh, wait, hold on, I forgot.
we do.
Okay.
Do the next one.
Nope, we're gonna do the last one together. All right, you guys, why don't we check in on these?
Are we providing with enough energy and the right orientation to overcome activation energy?
I think that's pretty photosynthetic. I think that's pretty Darwinian.
Underestimating now.
Photosynthetic.
Literally what? I don't know. It's okay.
Okay. So for this first one, our approximation using the left hand approximation. What did you guys get for that area?
20.25.
20.25.
Units squared.
Here, since this is for a video, I'll write out what it all is. So the width of each rectangle would be 1/2, and then the heights would be 8 plus 7.5 plus 7 plus 6.5 plus 6 plus 5.5, which ends up being 20.25. Okay, and then is this an under or an over approximation?
It's an under approximation. We know over, right?
Over.
Yeah, we start over.
Using that, yeah, over because
Because it's inscribed, and if the rectangles are outside, it should be outscribed, not superscribed.
It's
circumscribed. Circumscribed. It's an over approximation.
What?
Edit that out.
And these are circumscribed rectangles because the function is decreasing on each subinterval. So the left endpoint ends up corresponding to the maximum function value on each subinterval. Okay, then our area, our approximation for area, using the right hand approximation. What'd you guys get?
18.7.
18.75, and then I'm just gonna put that I'm not so worried about units at this point. We'll get there. 5.5 plus 5. Okay, and that is an under or over?
Under
Under, and what type of rectangles are those?
the opposite of circles. Inscribed.
What am I? I started combining the words. It's an under approximation. Okay, and those are inscribed rectangles. Okay, and then using geometric formulas to calculate the actual area, you could have used trapezoid, right? So look at the height of the two sides that are parallel to each other. What is it, 8 and 5? And then the height would be 3. So we end up with 39 halves, or 19.5, as being the actual area of that region. Okay, this one, we aren't able to come up with the actual area yet. Okay, we're trending in that direction. But for using the left end points,
Why don't we just do the under and over and do like an average or something?
trust the process. You can have the ideas, but we're trending in the right direction with this. Trust me. All right, so our area is going to be approximated using left-hand approximation. What'd you guys get for the left-hand approximation? 8.75. Okay, and then just to write this out, since this is the video, the width of each rectangle, because there's 4 rectangles, is 1/2. The heights are 2, 13/4, 5, and 29/4, where we end up with 8.75. Is this an under or an over? Under. I told you, easy but tedious.
So tedious.
Okay, which means we used inscribed rectangles. And then when we used the right endpoints, so our right-hand approximation, function values were 13/4, 5, 29/4, and 10. And that ends up being, what did you guys get?
12.75.
Me too. Okay. And that is an over approximation because we use circumscribed rectangles. And I can tell you the actual area of that region is 10.6 repeating, but we know that the actual area is somewhere between 8.75 and 12.75. The actual is 10.6 repeating, but we're just not quite there yet. Also, just wanted to point out, for figuring out what the width of each rectangle is, you can take the interval, right? So the interval from A to B, in this case, it was from 1 to 3. So 3 minus 1 to come up with the length of the interval, and then divide by the number of partitions that you want. So like in general, that would be B minus A divided by n number of rectangles that you're wanting to find the areas for, or n number of subintervals. Okay, questions? Do we understand what we're doing? Okay. So last one, except for the directions are telling us to approximate the area using inscribed and circumscribed rectangles that all have a width of 1. So if they all have a width of 1, here we go, I'm going to partition. Okay. And then for inscribed rectangles, we want to use the smallest function value on the subinterval for the height. So like the first rectangle, we're going to use the left endpoint, which it doesn't even necessarily have to be an endpoint, right? But we're not really going to get into the weeds there. Like technically the function could change from increasing to decreasing or decreasing to increasing on the subinterval. But would be the left endpoint there, and then would be the right endpoint on the subinterval from 2 to 3. Since the function's decreasing, and then the right endpoint on the subinterval from 3 to 4, and then, oh my goodness. The last rectangle. Okay, so let's focus on these. So adding up the areas of this rectangle, this rectangle, this rectangle, oh, and that last rectangle, which there isn't really anything there. The width of each rectangle is going to be 1. So the first function value we can see is 4 for the height of that first rectangle, then 4 again, then 2, and then 0. So the approximation for the area would be 10, which we know is an under approximation, right?
Yes.
When we use inscribed rectangles to approximate the area, this value is actually something that we refer to as being a lower sum. Okay, so I'm going to write this blurb out here. So using inscribed rectangles, and therefore always choosing the lowest or the minimum function value on each subinterval, we call this the lower sum, which we represent as lowercase s and then the number of rectangles that you have. So like this would actually be s of 4. And this is lowercase s. I feel like my writing's delayed. Okay, so new term going along with inscribed rectangles is calculating the lower sum. Versus for circumscribed rectangles, where we would want to use the largest function value on each subinterval for the height of the rectangle. So there's our first rectangle. There's the second one. Third. And fourth. So this area plus this area plus this area plus this area. Okay, so our approximation would be still a width of 1 for each rectangle, but the rectangle heights are going to be 5, 5 again, 4, and 2, which ends up being equal to, I have 16 written down. And when we're using the circumscribed rectangles, and therefore always choosing the largest function value or the highest function value, we call this value the upper sum, capital S of n. Or uppercase S. So like this would be capital S of 4.
What are those 3 dots?
Therefore, shorthand for therefore.
Oh.
Yeah, math people, for things that words that come up a lot, like to have a symbol. Not have to write it so often. Okay, so circumscribed rectangles, the areas added up correspond to the upper sum. And another way that you could see directions, like some alternative directions, could be like calculate the lower sum approximation for this area using like 4 rectangles. Something like that. Same thing, same calculation you would do, just different wording. Okay, so big idea for today is that we were looking at areas, different areas of regions that were bounded by a positive function in the x-axis on an interval, and we were approximating their areas using rectangles. Good?
Yeah.
Okay. So I know this is kind of a short lesson. We technically could move on, but I want to kind of let this simmer and process. I want you to think about like where we could be going with this. You have the rest of the period to work on the homework assignment.